Good morning, this is your Stat Sensei, Mr. Spensei, and this is going to be on contingency tables and learning how to read them and calculate probabilities. This video will be broken into two parts, which will be side one and side two. So side one is based on breast cancer. So 1 in 8 women will have breast cancer sometime during their lives. Many women have annual mammograms after age 40 to screen for breast cancer. Mammograms are not perfect and sometimes produce false positives, and they may also produce false negatives. In Stone Oak, 6% of women over 40 currently have breast cancer. 99% of the time, the mammogram will detect a cancer in women with breast cancer. The probability of a positive mammogram in women who do not have breast cancer is 0.03. Create a table showing all of your work. Well, at this point, the table's already been created for us. We don't need to worry about that, but let's look at a couple things. It says in Stone Oak, 6% of the women currently have breast cancer. And what that means here is that of all the women in Stone Oak, 6% have cancer. Well, 6% have cancer. 1 minus 0.06 gives me 0.94. All right. And since we're working with probabilities, it's always out of one whole. It has to be 100%. So this is 1 or 100%. All right. And the next thing we need to know is in Stone Oak, 6% of the women currently have breast cancer. We said that. 99% of the time, the mammogram will detect cancer in women with breast cancer. And if I take that 0.06, and why this is not something you have to know right away, but we'll learn later, 0.06 times 0.99 is 0.0594. So this is just that 0.06 times the 0.99, giving me that. Well, 0.06 minus 0.5094, 0.06 minus that equals 0.006. That just means we have 3 zeros in front. I know it's a -4, just go one less, that's 3 zeros. All right. It will also detect cancer in women with breast cancer. The probability of a positive mammogram, so looking at a positive mammogram and those without is 0.03. If I take 0.94 and multiply it by 0.03, I get 0.0282. And I take 0.94 and I subtract that and I get 0.9118. Please note this row plus this equals that, this plus this equals that, this plus this equals that, this plus this equals that, and this add up to 1. Couple definitions. On the outside, we have the marginal probabilities, and they've been marked in green right here. All right. Notice I did not mark this last box. This last box right here is the total. The total is not a marginal probability. Inside, and by the way, the marginal probability is just one variable, those that have cancer and those that don't have cancer, or those that are positive and those that are test negative. Then we have what we call our joint probabilities, all right? And joint probabilities are where we have two things occurring at the same time, positive in cancer, positive without cancer. So both things. And notice I use the word and because it's this and that. Negative and cancer, negative and no cancer. So that's just saying there's two variables involved here. There's one here, whereas on a marginal, there's only one variable. So let's get to the questions. So what is the probability a randomly selected woman does not have breast cancer? Well, we're interested in the part of this that says no cancer, and no cancer is right here. We're like, oh, 94%. Now, we always want to set it up as a fraction, even though right now it's just over 1, because sometimes it's not, these are not going to be percentages. If it's actual counts, it's not going to be a percentage. So set it up as a fraction. And so it's always going to be, in this case, marginal, because we're only worried about one thing, not having cancer over the total. So marginal over total, which in this case is no breast cancer, which we marked here, over the total of 1. So 0.94 divided by 1, and we just get 0.94 when we divide it out. The next one, what's the probability a randomly selected woman tests negative for breast cancer? Once again, we look and go, oh, negative. Well, negative is this right here. And it's like, oh, testing negative. It only mentions one variable. So if it's only mentioning one variable, it's a marginal. So we're looking for a marginal over the total. So it's 0.9124 over that one whole because it's negative, and this is supposed to be a negative sign. That's all that is. So negative over the total. The next one, what's the probability randomly selected woman tests positive for breast cancer? Once again, we're only interested in one variable. We're only interested in positive. So this is going to be a marginal over the total. Well, how many of them test positive? Well, looking for the testing positive, the percentage that test positive is 0.0876. Remember, the marginals are on the outside. They're everything on the outside except for the 1. So 0.0876 over 1. And we just get 0.0876. What's the probability that a randomly selected woman tests positive and has breast cancer? Okay, so this is the word intersect. This is and means intersection, and that means that's where the two cross. All right, so I'm going to switch over to a different table that's cleaned up, and we're looking for the intersection of where two things cross. All right, so let me fold the paper a little bit. It's going to take me just a moment. I should have done this earlier. So it says, what's the probability a randomly selected woman tests positive and has breast cancer? Well, the word and means we care about two things. In this case, test positive and has breast cancer. Well, anytime you have that, it's going to be intersection over the total. So this is going to be intersection over the total. So this is going to be a joint probability because you're looking for two variables. All right, that's supposed to be an intersection sign. And if you notice, the word and actually has the intersection sign in it. And like I said, that's the intersection sign. So test positive and has breast cancer. Well, test positive is right there, and has cancer is right there. And if you think about a street intersecting, oh, this is where they cross. It's like this is street 1, this is street 2. They intersected at 0.0594. So we have positive and breast cancer with an intersection right there, 0.0594 over 1. Okay, the next one. What's the probability that a randomly selected woman tests negative and has breast cancer? Well, once again, we're looking at two distinct variables, negative and breast cancer. So let's look at negative. Well, negative is right there and has breast cancer. Oh, that means they crossed right here at 0.006. So once again, it's intersection over the total. So intersection over the total. So 0.006 over the 1, the total amount, and that's our answer. The next one, what is the probability a randomly selected woman tests positive and does not have breast cancer? Okay, so test positive and does not have breast cancer. So test positive, that's right here. No cancer is right there. Well, we're crossing at 0.0282, so it's going to be 0.0282 over 1. Positive, and I really, and an intersection right there. So intersection over total, which in this case is positive and breast cancer. All right, I'm going to pause this for just a moment before we move to the next part of this. All right, continuing on. So looking at number 7, it says, given that a woman tests positive, and I'm just going to highlight that word given because there's two words that show up a lot that create a different situation. So it's given or if. If you see the words if or you see the word given, what that means is you're going to have the intersection. So you have a joint probability over not the total, but intersection over a marginal. All right, so you're going to have a joint probability. You're going to have an intersection over a marginal. So in this case, we go, given that a woman tests positive, all right, and by the way, the marginal is always going to go in the bottom. So given the woman tests positive, and so we're testing positive, and that's what we're given. And because that's what we're given, what is given always goes in the denominator. So I'm going to write that as well. Intersection over given. Well, what were we given? We were given that they test positive, so 0.0876 is going to go in the denominator. And that was our given. And it says, what's the probability she does not have cancer? Well, now I need the intersection, which is at no cancer. Well, no cancer is at 0.0282. So I end up with 0.0282 over 0.0876. I divide that out, I get 0.3219. So please note, it's intersection over marginal, which is intersection over given. This is super, super important that we keep in mind that it's anytime it says that it's intersection over given. The next one, explain the differences in your answers for questions 6 and 7. Well, what was question 6? This was an intersection over given. This is the first time that it occurred. And question 6 says, what's the probability randomly selected tests positive and does not have breast cancer? Well, test positive and not have breast cancer is this. The difference is this one doesn't say given and this one does say given. The key word there is given. And so this means it's from the group that tests positive, and this is from the total population. So number 6 was from the total population. Number 7 is only from the group who had already tested positive. So number 6 is out of the total sample or total group, total population, and number 7 is only out of the group that tested positive. They both have the same numerator, but the denominators are different because tested positive is only 8% or 8.76%, and the total population was 100%. All right, number 9, given that a woman, once again, we have given. Remember, if it's given, it's going to be intersection over given. So what were we given? Given that a woman does have breast cancer, so does have breast cancer. So this is what we're given. So that means 0.06. That's what I was given was 0.06. So that 0.06 is going in the denominator. What's the probability she tests positive? Well, testing positive, where's that intersection? Oh, it crossed, those two streets crossed at 0.0594. So 0.09594 divided by 0.06, and we have 0.99. Please remember, it's always intersection over given, intersection over the given if they use the word given or if. Given, oh, we have another given problem. Given that a woman does not have breast cancer, all right, so given no cancer, oh, this is what I was given. So if I was given no cancer, wait a second. All right, I'm sorry. Given the woman does not have breast cancer, well, the probability of not having it is 0.94. What's the probability she tests positive? Or test negative, excuse me. Given the woman does not, I'm on number 10. I got lost. Given the woman does have breast cancer, I got to pause for just a moment. I'm lost. Well, I apologize about that. I forgot what problem I was on. I was on problem number 10. Number 10 is a given problem. So it's going to be intersection over given. And we need to find out what we were given. And the words given tells me what's in the denominator, as does the word if. So given a woman does have breast cancer, well, they have cancer, this is my group. And that group is 0.06. And it says, what's the probability she tests negative? Well, negative, and remember it's intersection. Well, that's where the streets intersected at a 0.006. So we have 0.006 over 0.06, and that divides out to be 0.01. Okay, now moving on to 11. Given that a woman randomly tests positive, so all right, so we're testing positive. This is what we're given. And remember, it's intersection over given. So that tells me that in my denominator, I'm looking for 0.0876, which is what I have here, 0.0876. Because anytime it's given, hopefully y'all are getting this down, it's intersection over given. So we're given 0.0876 in the denominator. What is the probability she has breast cancer? What's the probability she has breast cancer? Well, we're going to have to go to the has cancer. It's like, oh, where do the pink streets intersect? They intersected at 0.0594 because remember, intersection over given, so 0.0594. Moving on to number 12. Given that a randomly selected woman tests negative, what is the probability she does not have breast cancer? All right, so we have a randomly selected woman testing negative. So testing negative, that's my green, and it's intersection over given. So intersection over given equals fraction line 0.9124. What's the probability she does not have cancer? Well, no cancer intersects right here at 0.94. So, and this is my intersection, 0.9118. I divide that out and I get 0.9913. Once again, intersection over given. All right, let me get a clean sheet. Number 13. Given that a woman does not have breast cancer, so what were we given? We were given they do not have breast cancer. That tells me 0.94 is going in the denominator. That's what we put there. What's the probability she tests negative? Well, this is this intersection, and testing negative is at 0.9118. And remember, once again, it's intersection over given. And the very last thing, it says, what are the differences in questions 12 and 13? All right, so 12 says, given the randomly selected, so it's also a given. Given the randomly selected test negative, all right, what's the probability she does not have cancer? And this one says, given a woman does not have breast cancer, what's the probability she tests negative? So basically, they swapped the order. This first one was randomly selected test negative. So the test negative was my group that it was taking out of. And over here, it's of the given the woman does not have breast cancer. So we have the same variables. So we're going to have the same intersection, but our denominators are different because the number 12 was out of the group that tested negative, and number 13 was out of the group that did not have cancer. So number 12 and 13 have the same intersection. So they have the same point where they cross. So which means our numerators are exactly the same, and they are. Um, and but number 12 is out of the group that tests negative, and number 13 is out of the group that does not have breast cancer. So basically, the groups or the denominators are what are different. All right, apologize for the errors, but I sure hope it helped anyway. Look forward to seeing you on the next one. Thank you.